Vocabulary seems to be one of the hardest things for people to do in math, and that is understandable. This vocabulary that you see on this page is extremely important. You need to be able to name parts of an expression in order to communicate properly in math. So let's look at each one of these definitions. Up here I have the expression negative 7x plus 2x plus 8. Our first vocabulary word is the word terms. Terms are the parts of the expression between the plus signs. So these would be the terms of my expression. Coefficients are the numbers that come before the variables. So in this expression, negative 7 and 2 are the coefficients, because in this case, the 8 is not a coefficient because it doesn't have a variable part. And so when you have a number that does not have a variable, it means that it is a constant, a number that's not changing. So in this situation, the 8 would be our constant term. Like terms are terms that have the same variable part. In this case, we have a set of like terms, and that is the negative 7x and the 2x. Here's another example. I need to identify the terms of this expression. Again, remember the terms are the chunks, as I like to call them, between the plus signs. So we would list the terms of this expression using commas to separate them. 2x squared, 3x squared, and be careful here, that's a negative 14. Remember that subtraction is really the definition of adding the negative. So that's a negative 14 there. Your like terms are terms that have the same variable part. Well, this 2x squared and that 3x squared have the same variable part, the x squareds. So we either write those with a comma again or with the word and, indicating that we have a pair of like terms. Coefficients, remember, are the numbers before the letters in an expression with a variable. So that, in this case, would be the 2 and the 3, and you can just list them with commas again. And constant terms are terms that do not have a variable part. They are constant, not varying. That's how I remember. And so the only constant term we have is a negative 14. You try figuring out the parts of these two expressions, so pause the video and come back when you're done. Here are what your answers should look like. And there were a lot of interesting things going on in these problems, so let's talk about it a little bit more. The terms were pretty straightforward. The only thing to remember is to make sure your negatives come along with the numbers. Your like terms, we had two sets. We had like terms that had the same variable parts. But here, your constants are also considered like terms because they have no variable parts, and that's considered the same. The coefficients, again, just make sure you remember that negative sign in front of the 2. And we have two constant terms here, negative 8 and 5. In the second example, our terms are listed, but we do not have any like terms. Just because the same variable was used, it's not the exact same variable, because one is an x and one is an x squared, and you know that that means two different things. Here's an x, and here's an x squared, so those are not considered like terms. You do have coefficients here. No numbers are written before these two variables, and that means that there is really a number 1 there. So whenever you see a variable with no number written before it, it is understood to have a 1. The constant term is 5. So these problems here go back to our previous problem where we had an x and an x squared. It's important to be able to tell if terms are like terms or not. So go through each one of these examples and decide if those are like terms or unlike terms, and you can just write it off to the side, like or unlike. Remember, they need to have the exact same variable part, which means the letter and the exponent on that letter need to match. Go ahead and give it a shot. Pause the video. And here are the results. Like terms, unlike terms because the letters are different. Like terms because your variables and their exponents are identical. These are like terms because they're all constant. These are unlike terms because you have different powers. These are unlike terms because one has an x and one does not. And this last one, they're also like terms. Now here's the grand finale of this lesson. It's important to know that you can simplify expressions by combining like terms. And just as it says here, you can combine like terms by adding the coefficients of the like terms together. And if you have constants, they're like terms, and you can add those together. So let's look at example A. I'm going to put a box around a pair of like terms. 10x and 36x and 4x are all like terms. I have another set of like terms, and those are my constants, 6 and 1. Going back to my squares, if I have 10x plus 36x plus 4x, I can add those together and I get 50 x's. It's like 10 apples plus 36 apples plus 4 apples gives you 50 apples. I sometimes think of it that way. And then just grouping our constants together so we can see it, I have a 6 plus a 1, which is a 7. This expression here is the same as this one up here. It's just simplified because we combined like terms. Letter B is a little trickier. I have a distribution going on here. So if I was asked to simplify this, I would distribute that 6 first. 6 times 5 is 30, and 6 times x gives me a 6x. And then add on my 12x. So now you have to ask yourself if you can simplify further. And you can, because negative 6x and a positive 12x, when you add the coefficients together, you get a 6x. This 30 doesn't have any like terms, and so we just rewrite it down. And this makes kids uneasy. They don't like leaving like 2 terms there for an answer. They like one answer. But you're not going to get one. There's nothing we can do to these 2 problems here because we don't know what x is yet. Now it's your turn. Pause the video and try these guided practice problems. See you in a minute. Here are those answers. As always, let me know if you have any questions. Dig into it if you made any mistakes and figure out where. And remember, you can always watch this video again.